jumping in mid-problem. 1/2 mass of the beta particle times velocity of the beta particle squared. My YouTube viewers are going to revolt. I'm going to lose so many subscribers. Has anybody looked? How many subscribers do I have? Does anybody know? Last I looked, I was over 5,000.
Really?
I think we can monetize at 5,000. Yeah? Okay. No, then I might actually make enough money that I could quit. They don't pay me that much here, so I could probably equal it on YouTube. So now I have to find the ratio of the velocities. To do that, I have to get all the velocities on one side and then everything else on the other side. Right now I have 1/2 on each side. I can multiply both sides by 2 and get rid of that 1/2. I can just cancel it out. Right, so this is gone. We don't care about the halves. So I have the mass of the alpha particle, velocity of the alpha particle squared, equals mass of the beta particle times velocity of the beta particle squared. I'm going to do the thing that physics teachers always do that students hate. I'm going to do multiple algebra steps in one line. People like my YouTube videos because I don't do this, so turning it into a shithead. I want to get all the masses on one side and all the velocities on the other side. So I'm going to do that in one step. To do that in one step, I'm going to take the masses, I'm going to take the mass of the alpha particle, and I'm going to divide both sides by the mass of the alpha particle. That gets all my masses over to the right-hand side, right? Because my mass alphas cancel out. But if I want to do this in one step, I'm actually going to do it in different colors. How do I get now all the velocities onto one side? What do I need to divide by? V beta squared. Velocity of the beta particle squared. And if I do it to one side, I have to do it to the other. So the VBs are going to cancel on the right-hand side, but they're going to be left on the left-hand side. Yep. All in one fell swoop. So now we have velocity of the alpha particle squared over velocity of the beta particle squared equals mass of the beta particle over mass of the alpha particle. But I want just the ratio of the velocities. What's messing me up right now? Those are velocities squared. How do I get rid of the squares? Take the square root of both sides. And I got velocity of the alpha divided by velocity of the beta equals the square root of the mass of the beta over the mass of the alpha. Okay, now I actually have to do this division. There are multiple ways you can do it. You can do it in multiple different kinds of units. If I want to do it in kilograms, let's do it in kilograms, SI units. I need to do the square root of the mass of the beta particle. What is a beta particle? What is beta-decay? Beta particle. Did we watch the lecture? I hope so. It's one of those depressing teaching days. What is a beta particle? Look in your notes, look at the book.
High energy, high speed electron.
High energy, high speed, what?
Electron.
Electron. So what is a beta particle?
Electron.
An electron. What's the mass of an electron? We've all memorized that, right? No, you can get it from an equation sheet. 9.11 times 10 to the negative 31 kilograms. So a beta particle is an electron. And then I need to divide by the mass of an alpha particle. What is an alpha particle? Not a proton. That would be nice. Not an electron. Beta particle is the electron. Not a neutron. What is an alpha particle? You go up, bust out your phones and ask Siri. Siri knows. Or Google knows. Helium nucleus.
Is it?
Yeah. An alpha particle is a helium nucleus. How'd you know that?
Well, I was looking at my notes and it said alpha decay involved in helium.
Uh-huh. That's why they call it alpha decay, because it's a helium nucleus pops out. So helium nucleus, here we're going to introduce a new kind of unit. 4.002 U. What is that little U? This is from chemistry. Atomic mass unit. So this is what's in the periodic table, AMUs. How many of you have never used AMUs before? You've all used AMUs before? Okay. Now we take this AMU, and do we want the mass in AMUs? Can I divide kilograms by AMUs? No. What do I need to convert that into? Kilograms. So there's a conversion factor between AMUs and kilograms. That conversion factor is 1.6605 times 10 to the negative 27 kilograms in 1 AMU. So those U's cancel out. Plug and chug all your numbers in, and you should get V alpha over V beta is 1.17 times 10 to the negative 2. What are the units?
Oh, no.
Kilograms
No,
squared.
no.
I have kilograms divided by kilograms. What happens to the kilograms? They go away. No units in a ratio. Any questions on that one? Okay, let's look at number 17 then. Number 17. In the following 8 problems, write the complete decay equation for the given nuclide in the complete A, Z, X, N notation. Refer to the periodic table for values of Z. So for number 17, we want to do beta decay of H3, also known as tritium, a manufactured isotope of hydrogen used in some digital watch displays and manufactured primarily for use in hydrogen bombs. Anybody ever see Spider-Man 2?
Yeah.
The one with Dr. Octopus? And he's making fusion? He talks about tritium. So this is what he's using.
The thing he got from Harry's friend?
The little circle thing that he got from Harry, and he shot his little lasers at it. It's the scene where he breaks the little inhibitor chip on the back of his arms, which is a great idea, right? If you have this evil AI-controlled arms, the only way you control them, you want to make into a little glass chip that's really, really easy to smash. Yeah. Okay, so we need to do the beta decay equation for H3. How do we do this? Well, there's a general equation for beta decay, and this works for all beta decays. That general equation looks like this. We have X sub n Z A becomes A Z plus 1 Y n minus 1 plus beta particle plus this little thing. This is the general equation for beta decay. A, what did A represent? Atomic mass. And what is that? Protons plus neutrons. It's so what's Z? Atomic number, and what particle does that represent? Protons, what does N represent? Neutrons. So Z plus N is A. And what is X here? It's an element. And how do I know what symbol to put there? Periodic table. Which one of these will determine what element it is? A, Z, or N? Z.
Number of protons.
On the periodic table, the atomic number is the number of protons. So Z is how you find these. You can find it with A. That's the number that's listed underneath the symbol. But usually you go with the number in the upper left. So we look at the number of protons to get the element. And then, after we go through beta decay, we end up with the beta particle. And what is a beta particle? Electron. What's this weird thing? Anti-electron neutrino. So this little thing is called a neutrino. It's an extra particle that comes out of this reaction. It is essentially massless. Has no mass. And then we have, excuse me, fun to sneeze.
Bless you.
Damn it, scared it away. Come back with a vengeance. So what happens to A? Does anything happen to A? No. So does anything happen to the number of nucleons? No. So the number of nucleons is the number of protons plus neutrons. So that stays constant. How about the protons? What happens to the number of protons? Plus one. What happens to the number of neutrons? Minus one. So where do I go in the periodic table to figure out what element this is? The next one over. Z plus 1. So here we have beta decay of H3. So I have H with a 3 up top. That 3 tells me the total number of protons plus neutrons. How many protons are in hydrogen? 1. So how many neutrons are in this version of hydrogen? 2. Because I need 2 plus 3 to give me my A. 2 plus 1 to give me 3. Z plus N to give me A. Okay, so then I move over. What happens to my A? Stays the same. Keep that 3. What happens to my Z? Plus 1. So Z becomes 2. What happens to my N? Minus 1. So 2 minus 1 is 1. And then what happens to my symbol? Whatever Z equals 2 is. What is Z equals 2? Helium. Plus an electron, plus a neutrino. Here's what we start with. We know all of this. We know this because we were given the hydrogen with the 3 up top. We know that Z is equal to 1 for hydrogen. That's its atomic number. And we know that N is equal to 2 because we need to get that mass number equal to Z plus N. Then we go over 1. So we know all the numbers that we have here. We know A stays the same because that's what happens in beta decay. We know our Z increases by 1 up to 2. We know our N decreases by 1, so it goes from 2 down to 1. And we know this symbol is helium because helium is the second element on the periodic table. Plus an electron, plus a neutrino. Something else to notice about these reactions. Charge stays the same. Yep. So I always have to have the same charge on both sides. On the left-hand side, what's the charge over here? How many protons? 1 proton. How many neutrons? 2 neutrons don't do anything to the charge. So what's my charge over here? Plus 1. What's my charge over here if I just add helium? Plus 2. I want it to be plus 1. How do I get it to plus 1? What am I adding to this? Electron. What's the charge of an electron? Minus 1. So 2 minus 1 gives me 1. So I have 1 charge on the left, 1 charge on the right. Okay. Carrie had a question.
On decay, you're always going one over. On the periodic table, you're always going to the right one?
Yeah.
Okay. And then will you be doing this periodic table?
Yeah.
Or you will?
Yeah, you'll get a periodic table. You don't have to memorize the periodic table. There is, after this exam, there is a periodic, basically it's the physicist periodic table. It's called the Standard Model of Physics. You'll have to memorize that table.
Is it as big?
It's easy. I'm serious. There's only 25 things to memorize in it.
You mean for like our next physics class, or like after spring break? Will it like be
After Easter break.
Level?
The new stuff that'll be on the final exam. It's very easy though. Okay.
Do you have any plans for Easter break?
No, I'm gonna sleep. When is Easter break?
Next Wednesday to the Tuesday.
Next week. So what weekend? Is that the weekend Endgame comes out?
Yeah.
Yeah, I'm going to see Endgame on Sunday. Anybody else going to see Endgame? The new.
We're going on that Friday. That Friday.
That Friday?
Midnight.
How did you get your tickets?
My friend.
You must have logged in like right away.
Sometimes they do like creative ones on Thursday night.
Yeah. Yeah, I tried.
Probably also want
There were no tickets available.
That midnight release one?
It's insane. I haven't seen the Joker trailer.
That's good.
I've heard Shazam is really good. And my YouTube viewers are really loving this.
Yeah. Are you scared of that?
Okay?
You see the trailer? This kind of trailer?
So that's the reaction. So if you're asked to write out the reaction for some kind of decay, this is the equation you're looking for. And the general one can be applied to anything. This is always what beta-decay will do. Any questions on that one? No? The next one people had questions about was number 37. '37 is a little tricky. 37 is write the complete beta-decay equation for the neutron. What? How do we do that? I have a neutron. Doesn't have any A's or Z's or N's. How the heck do I do this? What do I know I have to get out on the right-hand side? There's two things that I know happen. This is beta decay, so what do I need?
Beta party.
I need a beta
Neutrino.
and a neutrino.
Neutrino.
So I know I have those. Yeah? Because it's beta decay. Got it. What's the charge on the left-hand side? Charge or neutral? Neutral. What's the charge on the right-hand side right now? -1. How do I cancel out -1?
Plus positive.
+1. How do I get +1 charge there? Proton. Boom.
That's it?
That's it. What? Whoa! Their brains are exploding in here, YouTube. Neutron on the left side. We're all good with that, yes?
Yes.
Now on the right-hand side, we're all good with beta particle, which is an electron, plus a neutrino. Why do we have that?
Beta.
That happens in beta decay, always. And then we also have another particle. Well, we need to figure out what that is. What's the charge on the left-hand side?
0.
Neutral. What's the charge on the right-hand side if I don't have that particle there?
-1.
-1. It's an electron. It needs to be the same charge. I have to conserve charge on both sides of this reaction. So how do I conserve charge? I need to get rid of that -1. Get rid of the -1 by putting +1 charge. And +1 charge you can get out of a proton. Okay, so the charge can stay. That's it.
the whole problem.
To the whole problem. Well, there's the second part where you have to talk about the mass. I'm not going to expect you to conserve masses. I'm going to expect you to write these equations out.
Find the energy release.
Finding the energy is very simple. To find the energy, you take the mass of a neutron, you subtract the mass of the proton plus the mass of the electron, and that gives you an energy difference. Every time you're doing these reactions, you're doing them and you're creating energy in the process. You're losing some energy, some mass, and that mass turns into energy. So you can figure out the energy that you get by taking mass of the neutron minus mass of the proton minus mass of the electron and multiply that by c squared. And you get the energy out. We don't care about that. So let's do number 38. Number 38. Write the complete beta minus decay equation for strontium 90, a major waste product of nuclear reactors. So we've got SR with a 90 up here. I should fill in the Z and the N for strontium, so I can get these bottom numbers. What is the Z for strontium? Where would I go to find that? Go to your periodic table and definitely look it up. The Z for strontium is 38. So that's what the Z is. How do I get this N?
90 minus 38.
90 minus 38. What's 90 minus 38? 52. So there's my strontium. And now I know exactly what's going to happen in beta decay. I'm going to end up with, well, I know I have a beta particle. I know I have an anti-electron neutrino. And I also know that I have, gosh, what happens to my A? Stays the same. What happens to my Z? Increases by 1. So whatever element is in position 39 on the periodic table is the symbol that I plug in. And what happens to my N? So what is my N? 51. I go to my periodic table. What number do I look at? 39. What is number 39? Y. It's ytterbium.
What?
Strontium turns into ytterbium plus an electron plus an anti-electron neutrino. Okay. Any questions on that one? Yeah. How do I know it's negative beta? The problem told me. Yeah. The problem says write the complete beta minus decay equation. Any other questions on that? No? Okay, so the last thing to talk about is to make sure that we all know all this terminology stuff. So for alpha decay, this is a good general equation to put on your sheets. Every time you have alpha decay, you have this on the left-hand side, this general kind of nuclide way to describe something, way to describe a nucleon. X is the symbol, A is, what is A? Atomic mass. What is Z? Atomic number, which is the number of protons, and what's N? Protons plus neutrons gives you the A. Z plus N gives you A. So always have that on the left-hand side. If I'm doing alpha decay is spitting out a helium nucleus. So I know that I have a helium. Helium right there. What's the atomic number of helium? 2. What's the atomic mass of helium? Do you remember this? Helium has 2 protons and 2 neutrons. So what's its atomic mass? 4. If this is what I have, what does my Y need to have with it? What happens to my A? Is my A going to change? Here I have A. The total number of nucleons needs to remain the same. If I'm putting 4 into the helium, change by 4. I need A minus 4. How about my number of protons, my atomic number? If I have 2 protons out of this, how many protons do I have here? Z minus 2, so I conserve my protons. How many neutrons are in helium? 2. So if there are 2 neutrons in helium, what happens to my N? N minus 2. So this is a general formula for all alpha decays. Whatever symbol you have on X becomes whatever symbol on Y plus this helium particle. So this helium particle goes along with everything. That'll always be the same. These will change depending on what element is doing the alpha. You good on that? Yeah. And then beta decay. We've gone over one version of it. Beta minus. we have A, Z, X sub n becomes Y n minus 1, Z plus 1, and A, plus a beta decay, plus an anti-electron neutrino. We could also have beta positive decay. So we can have A, Z, X sub n. We're going to add a beta positive particle. So instead of adding an electron, we're not getting out an electron, we're getting out a positive electron. What's a positive electron? Positron. So we're getting out a positron. If I'm getting out a positron, how is that going to change these numbers, these letters? It's going to be opposite. So what's Z going to be? Z minus 1. What's N going to be? N plus 1. So that is positron. Okay. These are all different forms of beta decay because they all involve electrons or electrons' version of antimatter, the positron. And finally, we have something we call electron capture. We have A, Z, X sub n. And the weird thing about this one is the stuff that happens is actually on the left-hand side of the equation rather than the right-hand side. So I have an atom sitting out there, and it's going to actually grab an electron. So if I do that, in order to conserve my charge, I now have on the right-hand side number of nucleons stays the same. The atomic number now decreases by 1, and I end up with 3. Okay. Those are the main types of decay. What's the third kind of decay that you can have? So alpha has 1 equation, beta has 3 different ways you can decay, and the last one was gamma. Yeah, Carrie. 22?
Yeah.
Let me look at it.
It's electron capture by IN1.
Okay. So electron capture by IN 106. Okay, so we need to bust out a periodic table. Somebody bust out a periodic table and tell me what is IN. 49? Okay, so it's IN. 106 is the mass number, 49 is the atomic number. So how do I get the number of neutrons? 106 minus 49, what do we get? You said 57? Yep. Okay, and what am I going to add to that if this is electron capture? Plus an electron. And then what am I going to get out? What happens to my A? A stays the same, 106. What happens to my Z? Minus 1, so I have 48 down here. What happens to my N? Plus 1, 58. Plus an electron neutrino. So I followed this algorithm. My A stays the same. My Z decreases by 1, so I go from 49 to 48. And my N increases by 1, so I go from 57 to 58. Now I need to look at the periodic table and see what symbol is 48. CD. So there's your electron capture equation. Any questions on that one? Any other questions? Yeah.
Number 7, what formula would we use to find the radius? Would it be the R naught A 1/3?
Let me look at number 7.
For the radius of
Radius of an alpha particle. Let me find the equation. So to find the, you would use R equals R naught A to the 1/3.
what would the A be? Would that be?
A is the mass number of helium. Anything else? Yeah.
Are you gonna put this on for
That's on the schedule, right?
Yes.
Yeah.
I'm just like jumping,
Right now, so I don't have a Jeopardy review written, and I won't have time to write it because I'm staying up from Friday to Sunday to strap this person to the board and they're doing planking correctly. I probably shouldn't have recorded that.